Hi all, let's start Maths grade 11, chapter 1, sets, subtopic Venn diagram and operational sets. Learning objectives. After this session, learners will be able to analyze Venn diagram for given sets, use Venn diagrams for union, intersection and difference. Fact. Venn diagrams are named after English mathematician logician John Venn. Venn diagram. Definition. Most of the relationship between sets can be represented by means of diagrams which are known as Venn diagrams. Example. Here, if universal set is having 1, 2, 3 till 10, then and A is 2, 4, 6, 8, 10 is a subset. Therefore, we can represent A as a subset which consists of 2, 4, 6, 8, 10, and the universal set consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Second example. If U is a universal set of 1 to 10 is, then B is with its elements 4 and 6 and A is 2, 4, 6, 8, 10. If we observe here, these elements of B are already presented there in this A. Therefore, we can write as a B as a subset of A. Therefore, first we have written B as a subset of A is a representation 4, 6 and here A is consists of 2, 4, 6, 8, 10. The universal set is 1 to 10. Operational sets, union of sets. The union of sets A and B is set C, which consists of all those elements which are either in A or in B, including those which are in both. In symbols, we write A union B is equal to X such that X belongs to A or X belongs to B. So this is A union B. So it should be either in A or it should be in B. The union of two sets can be represented by Venn diagram as shown in the figure. Some properties of operation of union. A union B is equals to B union A, commutative law. A union B union C is equals to A union B union C, associative law. Third one, A union empty set is equals to A. So, law of identity element. So, here an empty set is the identity of this universal set. A union A is A, idempotent law. U union A is U, law of universal set. Intersection of sets. The intersection of sets A and B is the set of all elements which are common to both A and B. The symbol here is a mirror image of this U, is used to denote as this intersection. So, the intersection of two sets A and B is a set of all those elements which belongs to both A and B. Symbolically, we write it as a intersection B. So here the intersection is like it's reflective that one to this one. X such that X belongs to A and X belongs to B. Disjoint sets. If A and B are two sets such that A intersection B is a null set, then A and B are called as a disjoint set. Because if no element is common between the two sets A and B, then we call the two sets as disjoint sets. Some properties of operation of intersection. A intersection B is equals to B intersection A. It is commutative law. A intersection B intersection C is equals to A intersection B intersection C, associative law. Null set, an empty set, intersection with any set is the null set only. Similarly, universal set intersection with any set is A. So that's the law of empty set and this universal set. A intersection A is A, idempotent law. A intersection B union C is equals to A intersection B union A intersection C, distributive law, that is distributes over union. Venn diagram representation of distributive law. A intersection B union C is equals to A intersection B union A intersection C, distributive law. That is here intersection distributes over union. For example, when we write the B union C, we will get this is a part. Then A intersection B union C is equals to, which is the combination of here, this is which is common for both that one. So this is a shaded part. Therefore, this is A intersection B union C. Third one, here A left side, if you consider this right side, that is A intersection B union A intersection B. So here A intersection B is which is common for A and B. This is the shaded part here. The second one here, A intersection is which is common for A and C. This is A intersection C. Then A intersection B union A intersection C is this is which is common for A and B as well as which is common for A and C. So if we observe here, this A intersection B union C is equals to A intersection B union A intersection C. From these two diagrams, this is equal. This is called as distributive law. Difference of sets. The difference of sets A and B in this order is set of elements which belongs to A but not B. Symbolically, we'll write A minus B and read it as A minus B here. So, which belongs to A and but not to B. Note that A minus B, A intersection B, B minus A mutually disjoint, that is intersection of any of these sets is a null set. For example, here A minus B is separate one and this A intersection B which is separate here in the B minus A as shown in the figure. Exercise 1.4, question number 1. Find the union of each of the following pairs of sets. Solution. Here first one, given that x is equals to 1, 3, 5 and y is equals to 1, 2, 3. Therefore, x union y is equals to 1, 2, 3, 5. Second one, given that A is equals to AE, IOU and B is equals to ABC. Therefore, A union B is equals to ABCE, IOU. Third one, A is equals to x such that x is a natural number and multiple of 3. This implies set A consists of elements 3, 6, 9 and 12 so on, which are multiples of 3 as well as the natural numbers. And set B, x such that x is a natural number less than 6. So it will be 1, 2, 3, 4, 5. So set B consists of elements 1, 2, 3, 4, 5. Now we need to find union of this one. Therefore, A union B is equals to 1, 2, 4, 5 or multiple of 3. Fourth one, A is equals to x such that x is a natural number and 1 less than x less than or equal to 6. Therefore, it implies A is equals to 2, 3, 4, 5, 6. B is equals to x such that x is a natural number and 6 less than x less than 10. This implies B is equals to 7, 8, 9. Therefore, A union B is equals to 2, 3, 4, 5, 6, 7, 8, 9. Fifth one, given that A is equals to 1, 2, 3 and B is equal to an empty set. Therefore, A union B is equals to A itself, nothing but which consists of elements 1, 2, 3. So, whenever we are unioning with the empty set, so it will be the same set itself. Let us see question number 2. Let A is equals to A comma B and B is equals to A comma B C. So B consists of the elements A, B, C and A consists of elements A comma B. Is A, set A is subset of set B? What is A union B? Solution. Given that A consists of elements A comma B and set B consists of element A comma B comma C. So by observing here, all the elements of A are in B also. Therefore, A is subset of B. So therefore, A is subset of B. Yes, answer is A is subset of B. Then A union B is equals to A, B, C. Elements with us A, B, C, which is equals to set B. Let us see question number 3. If A and B are two sets such that A is subset of B, then what is A union B? Solution. If A and B are two subsets such that A is subset of B, then we can represent this in the pictorial way like A is subset of B. Then A union B is B itself. Let us see question number 4. If A is equal to 1, 2, 3, 4, B is equals to 3, 4, 5, 6, C is equal to 5, 6, 7, 8 and D is equal to 7, 8, 9, 10. We need to find A union B, A union C, B union C, B union D, A union B union C, A union B union D, B union C union D. Solution. Given that A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6, C is equal to 5, 6, 7, 8, D is equal to 7, 8, 9, 10. So these are the elements in this each set. Then we need to perform A union B. So A union B is equal to 1, 2, 3, 4, 5, 6. Because in this B and A, 3, 4 are common. So it's a 1, 2, 3, 4, 5, 6. Next, A union C. So when you are comparing A and C here, 1, 2, 3, 4, 5, 6, 7, 8 is A union C. Therefore, A union C is equals to 1, 2, 3, 4, 5, 6, 7, 8. Third one, B union C. By comparing this one, we can write as B union C as 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Fourth one, B union D is 3, 4, 5, 6, 7, 8, 9, 10. Here, B value is 3, 4, 5, 6 and the D is 7, 8, 9, 10. So, when you are comparing this one, so no element is common. So, 3, 4, 5, 6, 7, 8, 9, 10. Fifth one, A union B union C. We already know A union B is 1, 2, 3, 4, 5, 6. When we are unioning with a C, extra we need to add 7, 8. So, the value here is 1, 2, 3, 4, 5, 6, 7, 8. Sixth one, A union B union D. Already we know A union B. So unioning with this D. So we need to add up 7, 8, 9, 10. So A union B union D is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Seventh one, B union C union D. So here when we are unioning this B union C, we are getting this 3, 4, 5, 6, 7, 8. When we are making that union with the D, so extra elements are 9, 10 we need to add. Therefore, B union C union D is 3, 4, 5, 6, 7, 8, 9, 10. Let us see question number 5. Find the intersection of each pair of sets of the question 1 above. Here, for the question 1, there is a reference given. These are the sets. We need to ensure the union, we need to find the intersection. Solution. Given that x is equals to 1, 3, 5 and y is equals to 1, 2, 3. So, x intersection y is equals to 1, 3. Intersection means which is there both in A, x and y. Therefore, 1 and 3 are present in both x and y. Therefore, x intersection y is equals to 1, 3. Given that A is equals to AEIOU and B is equals to set with the ABC. Therefore, A intersection B is a set with the element A. Third one, A is equals to x such that x is a natural number and multiple of 3. This implies A is equals to 3, 6, 9 and so on. And x is such that x is a natural number less than 6. This implies B is equals to 1, 2, 3, 4, 5. Therefore, A intersection B is equals to, if you observe here, the only common element is 3. That's it. Therefore, set with the element 3. Fourth one, A is equals to x such that x is a natural number and 1 less than x less than or equal to 6. This implies A is equals to 2, 3, 4, 5, 6. B, x such that x is a natural number and 6 less than x less than 10. Therefore, this implies B is equal to 7, 8, 9. Therefore, A intersection B is an empty set because no element is common between A and B. Because A is still 2, 3, 4, 5, 6 and B is 7, 8, 9. So, no element is common. Therefore, this is an empty set. Fifth one, given that A is equals to 1, 2, 3 and B is equal to an empty set. Therefore, A intersection B is a null set and an empty set. Question number 6. If A is equals to 3, 5, 7, 9, 11, B consists of the element 7, 9, 11, 13 and set C consists of element 11, 13, 15 and set D consists of elements 15 and 17. We need to find A union intersection B, B intersection C, A intersection C intersection D, A intersection C, B intersection D, A intersection B union C, A intersection D, A intersection B union D and A intersection B union C. And last one, A union D intersection B union C. Solution. Given that A is equal to 3, 5, 7, 9, 11, B is equal to 7, 9, 11, 13, C is equals to having this elements 11, 13, 15 and D with the elements 15 and 17. Then A intersection B is, if we observe here, A and B, the common elements are 7, 9, 11. Therefore, A intersection B is 7, 9, 11. B intersection C. If we observe here, B intersection C here, only 11 and 13 are common. Therefore, B intersection C is 11 and 13. A intersection C intersection D, we can write it as first A intersection C. So, we need to find what is common here, A intersection C. That is 11 intersection with 15, 17. Therefore, what is the combination of this one is an empty set. Therefore, A intersection C intersection D is a null set or an empty set. Fourth one, A intersection C. If we observe A and C, there is a common element in this one is 11. Therefore, this A intersection C is a set with the element 11. Fifth one, B intersection D. If we observe here, B and D, there is no common element. Yes, the B 7, 9, 11, 13 is there. D 15 and 17 is there. No element is common. Therefore, B intersection D is an empty set. Sixth one, A intersection B union C. First, we'll take this B union C. B union C we are getting as 7, 9, 11, 13, 15. 7, 9, 11, 13 and 15. Plus 11 and 13 already repeated. And A is having set of elements with 3, 5, 7, 9, 11. If we observe in this one, the common elements of this one is 7, 9, 11. Therefore, A intersection B union C is equals to 7, 9, 11. Please turn over. Continuation of question 6. Given that, now let us see 7th one. A intersection D. If we observe here, this A 3, 5, 7, 9, 11 and D is 15 and 17. No element is common. Therefore, A intersection D is a null set or empty set. 8th one. A intersection B union D. Here, A is 3, 5, 7, 9, 11 and the B union D is 7, 9, 11, 13, 15 and 17. Therefore, A intersection B union D is 7 and 9. Ninth one, A intersection B union C. Between A and B, there is 7, 9, 11 are common. Therefore, A intersection B is 7, 9, 11 intersection B union C. When we are combining B with the C, we are going to get 7, 9, 11, 13, 15. Now, among these two, which are the common here? 7, 9, 11. Therefore, we are going to get the answer as A intersection B union C is 7, 9, 11. Let us see 10th one. A union D intersection B union C. A union D means we are combining A with a D. So 3, 5, 7, 9, 11, 15 and 17. Then intersection B union C. 7, 9, 11, 13, 15. 7, 9, 11, 13, 15. Therefore, this common elements between this is 7, 9, 11, 15. Therefore, A union D intersection B union C is equal to set with the elements 7, 9, 11, 15. Let us see question number 7. If A is equal to X such that X is a natural number, B is equal to X such that X is an even natural number, C is equal to X such that X is an odd natural number and D is X such that X is a prime number. We need to find A intersection B, A intersection C, third one A intersection D, fourth one B intersection C, fifth one B intersection D, sixth one C intersection D. Solution. A is X such that natural number 1, 2, 3, 4 and B is even natural number means 2, 4, 6 and C is odd natural numbers means 1, 3, 5. D is prime numbers 2, 3, 5, 7, 11, 13 like that. Now let us see A intersection B. Between A and B, between natural numbers and even natural numbers, even number is a natural number common. So A intersection B is even natural numbers, that is nothing but B. Second one, A intersection C, that is equal to When we are combining natural numbers along with the odd natural numbers, that's a subset of this, intersection of this one is 135, which is nothing but x such that x is an odd natural number. This is nothing but C itself. Therefore, 135 will representing with the set C. So, therefore, A intersection C is C itself. Third one, A intersection D is 2, 3, 5, 7. That is equals to x such that x is a prime number. So, that is equals to D, set D. Fourth one, B intersection C. B is even numbers and D is a prime number. So, B intersection C. C is odd natural number. Therefore, this is no number is common between the even numbers and odd numbers. Therefore, this is null set. Fifth one, B intersection D. B is even natural number 2, 4, 6 and D is prime number 2, 3, 5, 7. So, only one number is common, that is a 2. Therefore, B intersection D is 2. Sixth one, C intersection D. C is odd natural number and the D is prime number. So, which is a common here? The common value is odd prime numbers. C intersection D is odd prime numbers. Let us see question number 8. Which of the following pairs of sets are disjoint? 1, 2, 3, 4 and x such that x is a natural number and 4 less than or equal to x less than or equal to 6. Second, AEIOU and CDEF. Third one, x such that x is an even number and x such that x is an odd integer. Solution. First one, 1, 2, 3, 4 and x such that x is a natural number and 4 less than or equal to x less than or equal to 6. So, x such that x is a natural number and 4 less than or equal to it consists of this 4, 5, 6. Now, what is the common between 1, 2, 3, 4 and 4, 5, 6? So, 1, 2, 3, 4 intersection 4, 5, 6 is 4. Element is 4 as it consists of the element 4. This is not a disjoint set because this pair is set is not disjoint. Now, AEIOU and CDEF. So, what is the combination in this one? If this the both elements E is common, both the sets, therefore AEIOU intersection CDEF is a set with the element E. Therefore, it is an odd integer. It implies that when we are combining this, there is no common element between the even integers and the odd integers, odd numbers and even numbers. Therefore, this set is having this no common element. Therefore, this set is disjoint. This pair of sets is disjoint. Let us see question number 9. If A is equal to 3, 6, 9, 12, 15, 18, 21 and B is equal to like this, see there we have given some numbers in this one. We need to find here minus operations for this given. Let us see first one. Given A is equal to this one, we need to find A minus B. A minus B can be written as which is present in A but not B. So, we can write it as A minus A intersection B. Therefore, we can write 3, 6, 9, 12, 15, 18, 21 minus of 12 we need to because 12 is common between A and B. Therefore, the value here is A minus B is nothing but 3, 6, 9, 15, 18, 21. Similarly, A minus A is nothing but which are in A but not common for this both A and C. So, therefore, if you observe here A and this one, so we will get the answer as 3, 9, 15, 18, 21. Third one, A minus D can be written as A minus A intersection D. If we remove this which is a common here this between the A and D, we will get the value as 3, 6, 9, 12, 18 and 21. Fourth one, B minus A is equals to B minus B intersection A, that is equals to 4, 8, 16, 20. C minus A is equals to C minus of C intersection A. So, if we see combination of this even, which are this, we have to remove the common elements which are there. We are going to get 2, 4, 8, 10, 14, 16. Sixth one, D minus A is D minus of D intersection A. So, between this D and A, the only element of common is 15. So, from D we need to remove 15. Therefore, we are going to get 5, 10, 20. Seventh one, B minus C is equals to B minus B intersection C. So, The value here we are going to get is 20. Eighth one, B minus D. Means B minus B intersection D. 4, 8, 12, 16. Ninth one, C minus B is equals to C minus C intersection B. That is 2, 4, 8, 10, 14, 16. 10th one, D minus B. D minus B can be written as D minus D intersection B. So, when we come to D intersection B, when a combination we will eliminate this one, 20 will remove that one. Then we are going to get 5, 10, 15. C minus D. C minus C intersection D. In this C and D, only common element here, this one is 10. So, in this entire C element, we need to remove this 10. Therefore, the value we are going to get 2, 4, 6, 8, 12, 14, 16. D minus C. D minus D intersection C. Between D and C, the only intersection value is 10. So, from D, we need to remove this element 10. Therefore, we are going to get 5, 15 and 20. Let us see question number 10. If x is equals to ABCD and y is equal to FBDZ, find x minus y, y minus x and x intersection y. X minus y. X minus 1 can be written as x minus of x intersection y. That is, x intersection y is, which is common in both x and y, is B and D. So, therefore, x intersection y is B, D. Therefore, x minus x intersection y is equals to ABCD minus of B, D. So, therefore, x minus y is equals to A, C. Y minus x. Y minus x is equals to y minus of y intersection x. Y intersection x is equals to B, D. Therefore, y minus of y intersection x is equals to FBDZ minus of B, D. Therefore, x minus y is equals to, in this one if we remove B, D, we will get there with elements F, Z. X intersection y. We already know that x intersection y is A, B, C, D and this intersection of F, B, D, G. So, only common elements are B and D. Therefore, this values are B and D. Let us see question number 11. If R is a set of real numbers and Q is a set of rational numbers, then what is R minus Q? Solution. Given R is a set of real numbers, Q is a set of rational numbers. So, we know that real numbers can be divided into two parts. One is this rational, it has this rational and irrational numbers. Therefore, real numbers minus rational numbers is equal to set of irrational numbers. Let us see question number 12. State whether the following statements are true, false, justify your answer. So, we need to verify if this given sets is disjoint or not. First one is 2, 3, 4, 5 set with this and the set with the element 3, 6 are disjoint sets. Second one, A, E, I, O, U and A, B, C, D are disjoint sets. Third one, 2, 6, 10, 11, 2, 6, 10, 14 and 3, 7, 11, 15 are disjoint set. Fourth one, a set with elements 2, 6, 10 and set with the elements 3, 7, 11 are disjoint sets. Solution. If A and B are two sets such that A intersection B is null, then A and B are called as a disjoint set. This is a definition of the disjoint sets. Therefore, let us see here. First one, 2, 3, 4, 5, intersection of 3, 6. So, it has this 3 as a common element. So, as it's not an empty set, therefore, the given sets are not disjoint set. Thus, the statement is false. Second one, AEIOU intersection ABCD is A is common here. So, the value is here. We are going to set with element A. But this is not equal to null set. Therefore, given sets are not disjoint sets. Thus, the statement is false. Third one, 2, 6, 10, 14 intersection with 3, 7, 11, 15 is, if we are, no element is common, therefore this is an empty set. Therefore, given sets are disjoint set. Thus the statement is true. Fourth one, 2, 6, 10 intersection with 3, 7, 11. No element is common here. So thus intersection of this one is an empty set. Therefore, the given sets are disjoint sets. Thus the statement is true. Thank you.